Okay, thank you, Putri. Al-Fatihah. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil anbiya wa mursalin sayyidina Muhammadin wa ala alihi wa sahbihi ajmain. Rabbi firli wa liwalidayya warhamhuma kama rabbayana shirara. Rabbi firli wa tub alayya innaka antat tawwabur rahim. Bismillahirrahmanirrahim. Allahumma iftah alaina hikmataka wa anshur alaina min khazaimi rahmatika ya arhamar rahimin. Allah Rabbi israh li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Bismillahirrahmanirrahim. Taha ma anzalna 'alaikal Qur'ana litashqa illa tazkiratan liman yakhsha tanzila mimma khalaqal arda was samawati al-'ula. Ar-Rahmanu 'alal arsy istawa lahu ma fis samawati wa ma fil ardi wa ma bainahuma wa ma tahta as-sara. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wasallam walhamdulillahi rabbil alamin. Amin.
Alright, amin ya rabbal alamin. So Alhamdulillah, and to begin this talk, we are pleased to invite our Faculty Dean, Professor TPR Dr. Jamalul Laili Abdullah, to deliver the opening remarks. Professor, the floor is yours.
Thank you very much, Putri Alina. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to everyone. Okay, I'd like to give a warm welcome to Architect Serina Hijjas, and thank you very much for your willingness to share your expertise, your experiences with the students and the lecturers here, and also see like our KPP, okay, as well as the lecturers from architecture, COSA, and also the students, and congratulations to the students for organizing yet another interesting talk today. And I know even during the PKP, now all of you don't get your sleep. You still have like to finish all your student work, so hang in there. And so congratulations to Archisa for today's event. And as I mentioned just now, really we are really grateful and really thankful to Architect Serina for your willingness to join us today. And then so I think a couple of years ago, so we had Architect Hijjas to give a talk, and I think just recently also another one. He's currently our adjunct professor, and we're really grateful for him willing to be our adjunct professor. But today is for Architect Serina Hijjas, like the talk on sustainability in building designs, high-rise. And this one will help especially for the students Master of Architecture 02 who are doing their studio this semester on the high-rise. And so, and hopefully, I'm sure that Architect Serina will be able to share input regarding designing the high-rise that will go with nature and to reduce carbon dioxide, and then to provide basically what we can do to reduce the effect of global warming. Okay, so once again, Architect Hijjas, thank you, and I'm sure that all of us will enjoy your talk today. And then to the lecturers and the students from Archisa, congratulations, and inshallah the talk will be very beneficial to all of us, and it will be an interesting talk, and I'm looking forward to listening till the end. Okay, over to you, Putri Alina. Thank you.
All right, thank you, Professor TPR Dr. Jamalul Laili. So back to our main objective for today. Today's talk is to share and discuss knowledge regarding high-rise to low-rise towards net zero. But before I pass the mic to our honorable speaker for today, let's talk a little bit about Serina Hijjas. So she is a board member of Malaysia Green Building Confederate and a founding member of the Green Building Index. So as we all know, that's GBI. So she has 30 years of experience in the field of architecture, architectural planning and design, graduated from Bartlett School of Architecture and University of Sydney, joined Foster and Partners in London for 3 years before returning to Malaysia, and is currently is the director of Hijjas Custody Associates in Berhad. So to summarize today's tentative is that the talk will be for about an hour, and we will have our Q&A session and a photo session. So without further ado, AR Serina Hijjas, the floor is yours. Thank you.
Thank you very much. I'd like to say good afternoon and thank you for inviting me to this talk. So I wasn't quite sure what I needed to cover, and I was told, yeah, high rise, but I think one of the reasons I wanted to bring you from, I would say, where I started and where I am now is that I want you to start thinking about low carbon and net zero. And I guess if I wanted to give you an analogy, it's the Bitcoin of the future. And so it is something we need to be familiar with and need to talk about it and basically just be part of the design. So good afternoon, Dean, Professor Jamalun Laili and Dr. Husna, Puan Nick Farhana, studio leader AR Putri Mayang, and co-studio leaders Puan Sharifa Asma and Josmin. So thank you very much, Central Studio, for organizing this. I had a bit of a lesson trying to use the Google. There's always yet another platform to be used, and I guess this is the first time I'm using Google platform. So thank you for that. So let's go straight into it. Okay, can you see the screen?
Yes.
Okay.
Thank you.
I tend to like using this because a couple of the talks is that we have the glass ceiling. Everyone talks about a glass ceiling in terms of diversity and women in architecture and things like that. What's the glass ceiling? For me, it's the green ceiling. I've never been concerned so much about diversity, and because I think it's similar at architecture school. It's a 50-50 between male and females at university. It was the same when I started, so I see it as equal opportunities, but I see what is the problem going forward is that we have a green ceiling and we've already reached that limit, and so it's every day on my mind how we can actually improve that. So I wanted to take you from high rise to low rise because I'm going to give you an example of why going to a low rise may be a better answer, but it's not low rise as you think, but low rise with density. I'm not going to present today some ideas that are being developed for Penang South Island because it's very controversial due to the fact that, you know, it's reclamation and all the rest of it. Only to say that in the approach to that island, working with BIG, which has been quite an honor, it's all about sustainability. It's all about reduction. It's all about putting back. Well, let's see if it actually happens. I think it has to go the way it has to go. Everyone has seen this, and why put it back up again? I think when I started talking about sustainability, we put this picture up, and you know, everybody could sort of understand we are basically consuming more than we can actually provide, and we would need 1.7 planets. Hence why we've got Tesla guys thinking about going to Mars. I wish we would be investing more about greening our ecology and saving our planet than actually spending the billions that we're going to Mars, but that's a different story and something else to think about. So Malaysia's ecological footprint is fairly high, and we really need to get to the next level now. So you know, this is something we talk about in Malaysian Green Building in terms of, you know, buildings. What you and I are creating basically contributes about 40% of what we call the global gas emissions, greenhouse gas emissions. And so if we can build smarter, for more for less, then we will basically be able to turn that around and reduce that. There's been various projects that we have been involved, some things that you've seen, some things that you've not. I must say I'm so sorry. We haven't updated our website for years, but we are doing that now, so that you know it's not just Archisa Hijjas and his designs, but most of us, there's a few of us that have been in the company and have actually been working and establishing a much wider language and a presence with the architecture we do. But when I first started, I did start with reducing and optimizing resources. This is just an image of a sketch design for Securities Commission, which you might see on Mount Kiara. But let's talk about our overconsumption. So our population stands at 32.77 million, and we have 31.2 million vehicles registered. That's almost a one-to-one when we talk about, and this is not counting bicycles, yeah? We're just talking about mobility. We're talking about motorbikes, lorries, cars, vans, etc. And that's almost a one-to-one. And there is an imbalance in this equation, as you can clearly see. Selangor alone, and Greater Kuala Lumpur, with a population of over 7, actually this may already be surpassed, has also about 7 million vehicles. So it's no wonder that we sort of see the mega highways that are mega levels of 6 levels coming into Kuala Lumpur, around the perimeter. So much so we're not even realizing how different it was so many years ago. It's not about being nostalgic. This is not the case. But if you go on the Middle Ring Road, you realize that there's just a plethora of highways and disconnect between the buildings, communities, and the road. So sustainable consumption and production really needs to be looking at getting more by using less. When I first started looking and measuring about the CO2 levels, parts per million in the air, you don't have to be too worried about what these numbers actually equate to, but I think just focus that these numbers have been ascending, and they always talked about the limit of 400 parts per million of CO2, but already in 2017, some 4 years ago, we surpassed that number. We are at 407.25. And what does that mean? We've actually passed the climate change level already. And this picture was taken, and I'm quite sure most of you, whether at university or before university, would have felt the haze. We had those years of burning fires and haze, and the air was not clear. And so then everybody could understand, what does parts per million mean? And everybody had their sort of measure. It's 230 parts per million in Klang, or 200, 150. And so we could understand what these parts per million are. And we could equate it to the kind of haze and sort of think, wow, okay, I understand what they mean by climate change. But here's the deception. Looking out today, after the pandemic of 1 year, the skies are clearer, yes, but there is a deception here because the numbers have still risen. This is 2021. And in 4 years, we have already reached 420. These are measured at North and South poles. That's why the ice caps are kind of melting, partially due to this, but of course it's also to do with the ozone layer. And so it's a deception. We think everything is fine, but actually it's still rising. And why is it rising? It's because it's for things that we have done 10 years ago is finally catching up with us. And so we are really trying to aim, we hear 2030, we hear these numbers 2030, 2050, the UN, the Paris Accord, things like that. These are basically kind of saying, guys, there's a wake-up call. We really need to get these numbers down. We really now need to be working at 50% reduced energy in everything that we are doing in order that we can catch up to a zero carbon neutrality. And that's going to be kind of tough. And the outcome of that is that we're just going to see, water rising, we're going to see more fires, we're going to see all sorts of other things affecting overheating and coastal flooding that's going to happen. So let's take a picture of this. It's not the iris, it's not, it's not a fruit, it's actually views of the ozone layer. In the year 2000, that was the size of the ozone layer, and after 17 years of reduction of non-refrigerants in the air, it has reduced, but it hasn't reduced to zero, even after 20 years. So the ozone has recovered, but to fully recover, it may take another 20 years to recover. And like everything else, we have a carbon budget. Everyone keeps talking about the 1.5 degree change, and 2 is the tipping point, but we've already arrived at 1.5. This is Penang, and if you've taken the measurements, Penang has taken the measurements of the mean temperature changes. We've already shifted. We are seeing these peak changes in temperature. And so is Singapore. But Singapore being very conscious about where they are, and of course being very clever in terms of how they want to promote the green city, they are now calling it their push to become a city in nature. Whereas Malaysia, we have a lot of nature and we have to actually preserve that. They are transforming their city, of course it's an island state, into a city of nature. That's because in the next 50 years, their energy consumption to cool down the island, what we call the urban heat island. This is a picture of urban heat island mapping. And what the reds and oranges and yellows mean is where the density is. So the higher the density, the more reflective, the more hot surfaces without greenery, the more hotter it's going to become. That's why in Singapore, they do what they call 100% green plot ratio replacement. Whatever you had already had a piece of land, replace it, put it on a green roof, put it on the vertical sides, everything else. We need to cool down our environment. And there's a very big push there. So there's fine balance of acting with the finite resources that we have. And the quicker we get to this, then the more it becomes normal for us and how we think. So from high rise to high density, let's talk about this a little bit. This was my first project. I was 26 when I came back, and I came back from working with Foster's, and I had this idea after seeing Deutsche Bank, Commerz Deutsche Bank by Foster's, where they had gardens on 3 sides. It's not influenced by Ken Young, by the way. It's influenced by Foster's when I was working there. Was the idea of basically putting gardens up in the sky. This is probably not the first. After Meseniaga is probably the first, and this would have been the second. But the difference in this one here was the idea of in an office building. Of course, we wanted the core to be naturally ventilated. As much as possible, we are looking to shift into a natural ventilation. But this is an IT tech building, and dust particles are really critical. And there's a lot of pollution in the air. So the cores could not, even though we allowed the core was in the middle, and we had the gardens on the right and the left, or the east and west sides of the elevation. By the way, even though the building looks quite high-tech, the orientation was passive design. And what we mean by passive design, especially dealing in the tropics, is that you need to have the north and south elevations are the longitudinal or the bigger elevations. The shorter elevations or the shaded elevations should be, as a rule of thumb, on the east and west side. And this building did that. On the east and west were the gardens. And the building was a series of wings, and then it was curved. And when we first designed it, as a process of design, it actually went straight up. And then there was a comment that it was not dynamic enough. And so then we actually slanted the building in so that it become more dynamic in terms of its form. And this was the first building that also had underfloor air conditioning. So these were the kit of parts of the building. You can see the cores right in the middle. It had double-decker lifts. As you go higher, especially in office, you need to consider double-decker lifts. This was before the date of high-speed lifts, where it was basically using traction for energy reduction. So this was before that, but we did double-decker lifts in order to get the efficiency of the vertical mover. So when you're doing high-rise buildings, you're really looking at the vertical mover and how to bring people up, and then after that, the experience of what they have up in the building. It's also the first building that the entire office is an underfloor air conditioning. Why underfloor? It's a void in the floor, and the aircon is basically pushed underneath that, because why? You feel cool air at your feet the fastest. And that way we could actually bring up the temperature. This is before the days when 23 degrees became the new norm in how to cool the building. Before, people used to throw in 14 degrees. They had to cool down the air and dehumidify it and throw it inside the office to cool down the space. And that's why people were feeling a lot cold and chill. In this case, you can actually up the temperature and then you extract the air from the top. It's a bit like convection cooling, if you like. And it has that kind of efficiency. So here's the important thing. This tower is ahead of its time. Ahead of its time because in the year 2001, it was already 50% energy reduction. It was performing at, and if you don't know the language of this, and you'll say, oh, this is all MAP information, it performs at 132.18. It's a bit like consumption of your car. You know, I buy a hybrid, I can use more petrol to get further. It's the same thing. So if you just look at the figure 132, it is almost half the amount. A typical office building at that time was 240 to 260 kilowatts per meter square per year. So it already had 50%, which is extremely difficult for a high-rise building at that time. It's got 40 to 50% reduction of CO2, no CFC ozone depletion refrigerants, and cooling-wise from the underfloor was 30 to 40%. So we were already looking at energy efficiency before the Green Building Index even came. Green Building Index came in 2010. So beyond at that time, energy efficiency was the sort of buzzword and the thing to look for. Now we're looking more than just energy efficiency. We're looking at waste, water, recyclable materials, and all the rest of it when we're constructing buildings. The next tower, so from 2001 to 2018, when this building was completed, the Selkom Tower, welcome, I don't know, you used to see the signboard that sort of said, welcome to Selkom territory. This is a montage of the building on site, and obviously during the course of time there's some value engineering. I've got to say that probably this is a lot more interesting from the facades on the east and west sides, and then we'll talk about this building because you'll say, oh my God, Serina, it's a completely glass building. You moved away from a building that was louvers, setback, all the rest of it, to a glass building. And how can it be energy efficient? How can it be green? What do you do to do that? Yeah. So the concept for this building is new vertical workspaces. This is before the time of co-working came about. You know, we've got a lot of co-working spaces now, but the future thinking for this tower was to have co-working in the office environment for Selkom Malaysia. And so this is the look of the building on the outside. Now, interesting enough, what you see on the outside, you may not even know what's happening on the inside, because this building doesn't express what is actually happening. Most buildings have a central core when we do office towers, yeah? We're not talking about residential. In residential, you pull it to the perimeter. In hotels, you pull it to the perimeter and all the rest. And of course, I'd love to pull it to the perimeter, but the site was very tight. It was just a rectangular box. And so what we did was we shifted the core from the center to the perimeter. And inside, we created a hybrid core where we actually vertically connected between the floors. And therefore, communities of the office workspace can actually connect between the floors internally without having to take the lifts. which in itself is quite a shift in thinking. It's subtle, but it's a big shift. This is the space inside. It's basically 3 floors of atrias that connect, and their office meeting pods that are inside the space where co-working meeting spaces are. And this is an office where, you know, any Selkom worker, maybe not so much at the board level, would be able to come in, and they are basically hot desking. They don't actually have their own office space. So it's a very different idea in terms of me and my desk. It's really about hot desking, and it's about I can work anywhere. And so working from home for Selkom has not been a big challenge because they were already thinking in this manner. This is some of the spaces. I wanted to show you this because coming back to the building and, you know, how do you treat the building envelope as in terms to cool the building down. So you notice these figures I put here, 39, 32, 53, 21. And you notice the compass here, this is true north. So true north is up this way, and the east and west would be on these 2 sides. Yeah, this is the true north, which means that you have to be careful about these facades in terms of more of the heat gain in your design from this side. So when we did the performance of what we call the building envelope, we call it the OTTV, which is the overall thermal transfer of the building envelope, to see how much you can how can you cool the building without, you know, overheating, one, and also allow basically less cooling to the building in terms of your energy to cool down the building. You notice that all the sides are not equal. On the long elevation, on the sort of northwest, it's 39. On the southeast, it's more because the sun is rising up. And I wanted to show you this because the north and south, let's say this was north and south, may still not perform the same way. It will be higher even if the envelope was exactly the same. But because of orientation, what I'm trying to tell you is orientation makes a difference. And when you cannot do the orientation where to shade the east and west or whatever, then you have to shade it, or you have to put louvers, or you have to build a different skin on that building in order to cool it. So orientation, passive orientation, even on a high performance building like this, matters. In this building, we'll be able to touch it. So behind the facade that you think is all glass, isn't all glass. It's actually the location of the toilets, naturally ventilated. So you see all these little slots. Obviously, I would have preferred to open much bigger slots, but my client didn't allow that. So on these 2 sides that are kind of northeast, southwest facades where more heat gain is, it's actually solid, and some areas naturally ventilated. So that means that I'm actually responding by moving the cores out to those locations, responding to that passive design. So it's really important that you consider when you're doing your design about that. And of course, this is the look of the building. This is the top of the building. It's where the cleaning cradle is, where the HUs, where the MAPs are on top of it, so they kind of insulate the space underneath. This is a look of the building from the front. So this building has a triple glazing because it's glass. Now, the only advantage to doing glass in the tropics when you do it is that maintenance is much easier in the long run. Because glass lets water run off it, it's a little bit more self-cleaning in that respect. In this building, when I came to specifying the glass with talking with the facade guys, I said, can I touch the glass like Taiwan 101, 108 or whatever it's called? Can I touch the glass without feeling it overheated? And that's how we design the facade. You can literally touch the glass because people are still sitting behind the glass. I'm not saying this is the only way to do. I'm just giving you how you respond to your building and still be able to cut your energy. But interesting enough, right? I don't know if you noticed the figures before. It was about 121 kilowatts per hour per meter square. And so it's not even as low as Telecom Malaysia, and this is 20 years later. High rise is difficult to get to under 90 for offices, but in a residential, it is easier to do. But going forward, what is the city of tomorrow looks at? What are the sort of things that we really should consider, not just because of where we are in climate, but also with regards to, for example, responding to the pandemic. I show this image because it inspires me in the sense that here is a rock and a hard place. These are hard rock formations, and yet greenery is growing from it. Now, I am not a fan of vertical greening, but I am a fan of horizontal greening. Why? Because maintaining a building that is vertically green on a high rise is quite difficult. But horizontal planes of green spaces is much easier and more practical in terms of response. So in this next housing, the idea was, how do you look at interlocking spaces? How do you look about bringing hybrid community spaces into your planning? I don't believe that the future is about single use anymore. I believe that it's all about hybrid living. And that is that you work, you live, you have a garden space underneath, it basically becomes a city within a city in that sense. This was a concept that we did where we were stacking the housing. And that's the other thing about housing. People don't want to feel like they're in a high-rise flat block because it's just like pigeonholes inside a space. People want to have some sense of their own community and spaces. One of the most successful housing schemes down in Singapore is the stack boxes done by Oli Shoyin. And that's because they feel like their community spaces, although I don't agree to the language, I think it's very, very hard. But the communities itself feel this sense of their own spaces. And by creating compartments and things like this, you are breaking down scale. Scale in a high rise that is basically feels too inhuman, and therefore you have to break down the scale. And the new paradigm is the tropical environment, is that the ecological plan and the ground plan, it becomes more and more important. If I could obliterate all the car parks that we're having in podium car parks, I would. And if I see any one of you trying to plan to something like that, I'd probably shoot you down. For me, car parks should not be in podiums. If you want, you can pull them out. They can become flexible and change later on to additional housing if you have the same floor to floor. But you pull it out so that your buildings come down to the ground and engage with the community. This is just some of the plans showing how the cross ventilation actually occurs in the unit, how the green spaces are, and then how you break down, spaces vertically to make it feel that the scale is more humane. So think hybrid living, and then I want to show you something, sorry I spelled this wrong, in low-rise density. This was a competition we did about a year and a half ago for Penang Future Housing. We didn't enter it, but we put it in for the PAN exhibition. And for us, it was an interesting exercise to do, only because affordable living and micro housing is such an important aspect for us. And if we can challenge the developers, I'm going to say this before you guys go out there, challenge them to show that it can be just as affordable, but better places and spaces for housing, so much the better. This is in the 70s or in the 60s. They were like 17-story public housing. Those of you who are too young to know Pekililing flats, but my grandfather basically lived and died in Pekililing flats. So I do know about, in a way, have seen how he's lived in that kind of space. And we really don't want this as our future. So we did a quick study and we looked all around Penang, and there were about 29 public schemes, 340 private developments, in total something like 74,000 total units, and the expected occupancy is 387. Now look at the numbers from left to bottom. They have basically increased densities from 78 units per acre to 96 to 148 to 173 to 230, 223 to 224. 224 units per acre, one forester. And it creates this, it continues to create this kind of environment which is both not conducive for the B40s. For me, if you want to put people in high-rise, you might have put the guys who can afford to be in a high-rise, who can afford the meters per square, who can afford the luxury of it. But you can't afford the luxury of in a high-rise for affordable housing. So we looked and we said, could we actually do it better? And so we studied the site and we said, could we look at something that's only 8 or 10 stories, communities, at 180 units per acre? And so this was our study for that site, breaking up the model, just thinking how we could be responsive to climate, having the big umbrella roof and chamfering back the building, engaging with the landscape and environment, creating community spaces and shaded streets and marketplaces and courtyards inside, and still get the kind of density that developers want. Can we change the typology of languages? So this building, we chamfered about 15 degrees. It was inspired by Moshdi Safdi's, I don't know if you remember, you won't know this building, but Moshdi Safdi's earliest housing, but his was basically a pyramid. Now that won't work in the tropical environment because there's a lot of heat gain. So if you reverse it and put it upside down, you have more of a chance. It's also inspired by Barcelona housing, where there is a low rise. These are only about 8 or 10 stories. They're within the block, but they create quite a great sense of community spaces. And this is the creation of what we were looking at. We called it the pixel, and essentially it's a study. And of course, on top of the roof, it means that you have urban farming, you have still the solar PV, you have recreational spaces, apart from the shaded streets and courtyards that you create underneath. This is the heart of some of the courtyards inside. And because we did the elevation in two-story blocks, it looks like it's only a 5-story building, right? It's actually 10 stories. So scale is revealed in a different way. If you combine double units, you can actually bring something to look like it is of a lower scale. And so this is what we insert into the location. There's some of the spatial studies, facilities, agriculture, green pockets, where the cores are, how we would build this. So it's obviously it's a study, but and my firm belief is this, that whatever you study now, you will bring into the architecture when you come in later. So, and this has been quite true. You know, we did a competition for Bank Negara, which had timber louvers all the way around the building, and it was elliptical. And you will see at the end another project that is being built and finished, and it has these attributes. So some things that you study now, they actually come back later. So affordable housing, please consider the ground plane. Please consider the natural ventilation. Please look at combinations of spaces. And then this was just our attempt on how we would build it using modular construction. And we measure the energy and water savings in this building. But it's all about creating a network of community spaces. And I think that's very integral as the architect about, you know, what can we bring tangibly as a sense of place So whilst I'm giving you numbers and datas and all the rest of it, the essence is that you still have to create a sense of place. Whether you back it up with nature and science, that's fine. And it's almost that you don't read it. Here I'm explaining all of it, but the back of it is still a sense of place that's more important. So ecology and building are becoming a really big merging language that I think we're going to see more and more. Because we need to respect and we need to repair the networks that we have here. This building, when we were working on it, you know, at the time when we were doing the concept was the time when Apple did the first concept with Foster's with the donut building. And these were the famous words that was said for that concept building. I would maintain 80% as landscape and only build 10%. And I thought, wow, that's really interesting. How can I do it for the Harriet Ward University? So it had a green park or landscape in front. And what we did is we lifted up this plane, if you like, and then we inserted the buildings underneath. And thereby we actually created 80% landscape and about 10% building as in roads, because you don't see the buildings. The buildings are underneath. This was our first kind of sketch, and you obviously see that, and this is a good thing for you to know, that we often start with something that's a little bit more expensive, and then through the process of time, maybe it's through value engineering and everything else, we actually cut back on that. As you can see, the elevation has a little bit more pixel elevation. It's probably something that I like to introduce because it breaks down the facade. But in the end, we didn't do that. For us, this building was north-south facing. So again, what a fantastic option here. Facing the lake, so we had cross breeze coming through, and we opened up some pockets of courtyards to come through, to bring the air movement through. And we used the roof as thermal cooling to the space. So you can see this is the Harriet Ward. We haven't finished the curve coming down because that is basically phase 2. This is to take about 3,000 students. You can completely walk up to the garden. It's quite steep at the beginning. What you don't see are these are the steps, and those steps come all the way down to the ground. So you can start from the ground and walk all the way up the building. And you have a wide balcony here, which is where the drainage point is. Very tricky to build a curved sloping roof and have grass growing on it. Because it's the same philosophy of basically water rushing down, right? So it's built in sort of staggered layers underneath to stop the rain from letting the land slide down. It has an internal street, so this is a section. Most important, guys, planning is easy. Please draw the sections. Draw how you want to bring the natural ventilation through. Think about it. Think about how the light you want, what quality of light you want to bring through in that space. And that you can only know through the section. Of course, you can do the 3Ds, but I can spot if the levels are not right on a 3D because I've used my hand and pencil. I cannot spot it if you are always on the computer. And really, it's not about being old style or new style. When we do a walkabout, I can immediately see that the scale is not the right scale, only because I've used hand to pencil. And this hand to pencil allows you to understand scale. So please don't forget to sketch and don't forget to draw before you go into the computer and do whatever parametrics you want. Obviously, you've got a much better way if you can get into parametrics now using Rhino and all the rest of it, because you can open up another way of building and looking. So it has an atria skin, atria on the top, and this is the skylights. I kind of wish we actually had light pipes coming down so that we could actually bring more daylight in, but without the heat gain. Some things you know when you finish a project, if you could have done something a little bit better. The important part of whatever you do is analysis. Getting to know your site, getting to know your context, and then analyzing what your solution would be for that site. This is TNB. It's actually the University Unit 10. It is TNB's Research Center for Energy and Solar. It's their engineering department. And that's not a hill it's sitting on. There's actually spaces underneath that. But in order to break down the form, it's probably a building that's inspired from our COE building, Center of Excellence in Seremban, which is quite an interesting low energy building, quite nice. But this is a university campus, and it's interesting because of the spatial study that was done for it. We basically created two parts, which we call it the vortex. We sort of opened up the spaces inside as a token to energy response, but also in terms of a spatial feeling. But it has a garden in the center. So it has a garden that is in the center of the Unit 10, TNB, we call it center. And this is the look of the building itself. And we call it open lab, sorry. And this is the garden inside the campus itself. So the spaces look out into this garden, and then the building rises around and above it. Interesting that there's a juxtaposition about, it's a cube, but the garden itself is fairly organic in terms of how it's planned inside to feel and look. So it's that juxtaposition, I think, that makes it quite interesting. It's under construction at the moment. And of course, it has this layer of sustainable design. And how airflow goes through. It has a double skin, but it's not a glazed skin. So you can see that it has aluminium louvers, and then the glass is set back. What that means is that the glass doesn't have to be so thick. It doesn't have to have a thermal property in terms of response. And we are using the louvers on the outside of the building to become the shading skin of this. Okay, I come to the last. I don't know how am I going for time. I've got another 10 minutes if we're going for 4 o'clock. So I want to introduce you to the idea is, can we achieve net zero? And there's a lot of talk about what net zero is all about. Malaysia GBC is developing a tool for towards net zero. And that's because globally, under the World GBC, we actually have a target to transform a lot of the buildings to net zero. Now, I find this a little bit hard in Malaysia because after 10 years, even GBI or UBBL MS1525 reference to energy efficiency isn't mandatory. It's mandatory in Singapore. It's not mandatory in Malaysia. Please, please, please give the support to become this so that we can transform all our buildings to become already energy efficient by 30 to 50%. At the minimum, if you're a certified building, you're already 30%. So we're talking about zero waste, zero energy, zero water, and carbon neutrality. I want to introduce to you the Malaysian Pavilion for 2021. We call it 2020 because Expo hasn't changed that. That's still being promoted as Expo 2020, even though it will open its doors in October.
Serina, I'm so sorry for interrupting you, but you actually have till 4:20 for your...
Yeah, okay, that's all right. I've got time. I'll slow down. No worries. Yes, I know. I was sort of looking at the time wondering, because usually I'm a lot faster, but I hope you're still with me, and I hope you still find it quite interesting. So, because sometimes if it gets too long, it's a little bit too much. But I think this one's going to be quite interesting for you. It's a very small building. And these are the concept images that we actually presented when we went in for competition. All the projects you see here are competitions. The days of when clients would just come to you and basically say, here, I'd like you to do this project is very small. Lots of clients, developers like to still hold competitions. Our idea is that the building should represent the story of sustainability through a couple of lenses. One is reforestation and restoration, because we are criticized a lot for not doing restoration or reforestation, that we cut down our timber and we clear our lands illegally and we sell our timber. So I thought it was important that we bring this to the attention that we are making some efforts. I won't say that we're doing the best we can. It's not as tight as Scandinavian countries, but compared to the Scandinavians that have lost already a lot, we're doing some changes. So we wanted the pavilion to talk about reforestation and restoration. We wanted to talk about sustainable plantation because we also get a lot of criticism. This is a pavilion that represents us. And so we have to address topics head on where we are criticized and actually show where we are doing better. So the criticism on Malaysian plantation is mostly from the US and the European, who are already farming corn, maize, sunflower, etc. as their own types of oil. So here for Malaysia, we are promoting sustainable plantation. In fact, there is a special department on sustainable plantation, but really it's about mixing and not having too much of plantation and stripping down and having still the forests surrounding this in order that we can balance the ecology. The other thing was in the canopy of trees. So our concept of the building was to lift the building up, put it on stilts, a little bit influenced by Malaysian tradition of building on stilts and using natural materials. So this is the building in plan. It's a series of pavilions that are connected. We call it Canopy 1, 2, 3, and 4. This is in section. You won't understand it until you see the 3D. Basically, we have lifted it off from the ground. We have built underground, but we've actually put it on stilts. And in the experience of the exhibition is about energizing today with cluster plantation, energizing about regrowth, about quintessence, which we have a cube. And this is the building itself. It actually is lifted off the ground for a reason. We're making both a statement that it is touching the ground lightly, both in terms of its impact. It is the first net zero carbon building in whole of Expo, despite it being one of the smallest. And it will be a net zero energy building because we are providing about 25% energy from PV. We've done some reduction of our energy use, but we are also buying solar energy from Dewa, which is Dubai TNB, if you like, in order that we replenish the energy from renewable sources. So at the very beginning, the story of biodiversity, water, material, energy was in the whole concept, and understanding how we would build in Dubai in terms that it reaches climate in terms of heat about 40 degrees. It's not a tropical environment. It is a temperate, hot environment. And in the winter time, in the summer, it rises to about 45 degrees. But this building is about 25.7% energy reduction. We will be doing tree plantation. This building is called Net Zero Carbon because we are monitoring how much embodied energy is in the material to build this pavilion. So I don't know if you know, but in 2015 we were also lucky enough to win the competition and do the Malaysian pavilion, and it was built out of timber. The idea there was that we would be able to take it apart and move it back to Malaysia. But because we build quite cheaply compared to other countries, it's just too expensive for us to bring it back to Malaysia because of the value. So here it's built in steel and timber. It's timber from renewable sources. The steel construction is so that we can recycle 75% of the building material, because when you build Expo, there's a lot of criticism that you build it and it's only for 6 months and then you take it down. So we needed that the materials that we use for construction are recyclable materials. We have a water reduction of about 85, even though it's in the desert. And this is the building itself. It's a net zero carbon and net zero energy. And I thought I'd just show you, it's coming to completion. It will be completed in 2 months. This is the Expo site. Yeah. Okay, I'm actually early, I know. But I think that's all I need to show. So I will pass it back.
All right, that was a very insightful talk. Thank you, Serina Hijjas, for the very insightful talk about how do we innovatively challenge these environmental issues that are hurting the earth. So now, I mean, we're quite early, but I think we can proceed to the Q&A session. So if any architects, lecturers, or students have questions, please do not hesitate to share them with us. You are free to open your mic now. And if you are feeling a little shy, you can put forward your question in the chat box. Okay, all right. So there's one question from Mol M. His question is, what is your definition of net zero buildings?
Okay, the net zero, a total net zero carbon building means, so I'll go to net zero carbon first. Net zero carbon means the total embodied energy carbon to construct the building from the use of steel, concrete. The embodied carbon that is in these materials is calculated. The construction is calculated. And for the number of years, basically you want to reach a total balance in the sense that you are creating enough, you are balancing that carbon. So for carbon, how you can balance that is with renewable energy. It's with reduction of the material types, with the recycled content of the materials that you have. And in the case of Malaysian Pavilion, we're actually going to be planting 500 trees. Why I say that is because for a very small building, it's only there for 6 months. It's very hard to get your total carbon reduction for such a short time. So we're actually planting trees as part of the entire cycle. And then when the building comes down, all the other materials, 75% of materials will be recycled and reused again. So that is in terms of net zero carbon. Net zero energy means that the amount of energy to run this building, you are basically using renewable energy 100%. Now it's very hard in a high-rise building. I'm going to tell you that right now, and I will tell you that it's probably impossible. It's not impossible in a low-rise building. That's why something like NUS University is a net zero energy building, is because 3 or 4 story building with total PV roof, the ratio is the roof area to the number of meters square for your floor if you want to get the PV balance, it's no more than 3 or 4 times the amount of area of your PV. That's just a rule of thumb to let you know. So the relationship is low-rise buildings can possibly get to a net zero, but if you were a factory, for example, it's really quite hard to do that because you've got production that you have to entail. So you basically have to either buy from the grid more renewable energy, or you have to do I wouldn't use we're not a favorite of carbon trading, but so that the first thing you want to do is reduce your energy consumption by 30 to 50%. And then you want to balance it with renewable energy. That's to get to a net zero. So when the countries are saying we're targeting Singapore by 2040 to be net zero, which is 20 years from now, they're basically looking for renewable energy sources, and they're also looking to reduce the heat island. Then they are looking into CLT construction for recycling and the building materials and low embodied energy materials. These are the aspects. How has Hijjas done their efficiency calculation? Is it done in-house or through separate consultants? In-house, what tools are used? Okay, so we are not doing our own calculations. We actually work together with facilitators and MAP when we're doing the calculations. We should be able to go into doing our own calculations. I mean, I am a certifier, and so I should be able to do, but, and we've trained everybody in terms of GPI, mostly in the office now. But no, we're not doing the calculations because it's tied up to the MAP performance. So we actually haven't been doing that ourselves.
All right, Serina, Serina, I have a question for you. There's this new thing. I don't think it's a new thing. I think it's 2 years back. Engineers are starting to introduce plant-based building materials, where we use seaweed or kelps, or maybe recycled materials, or maybe shredded paper for construction materials. And now my question is there any consideration or any discussion about allowing it to be in Malaysia, and as well as considering it to be a part of a GBI
requirement?
Yeah.
I think the science of these, I mean, you know, we have 3D printing for building houses now, right? So 3D printing has come into building houses, and you're seeing some houses being built out of 3D printing, and that will be coming in, I think, more and more for single, or maybe it may come into terrace houses, but I see the experimentation on that. I see the experimentation on green concrete, which means green concrete means, you know, for floor slab you put bubble, what we call bubble balls inside there to reduce the amount of concrete material that you're using. But I think for recycled materials, the testing, the fireproofing element of it is still a bit low. CLT though, cross-laminated timber, we're seeing, you know, 20-story buildings being built out of timber, and the idea here is that you grow timber and you build. There's something that you can grow and build, and hence why I think that the way of the future will be that it's low-rise densities and you're building in this manner. Because high-rise, even though China is showing that I can build a building in 3 days, you know, I can erect 10 or 15 stories in 3 days, it's all still prefab. And we've looked at prefab in terms of 3D fabrication with a developer, and it's a lot of concrete base. The hybrid materials still have not come in, and they're still not at a price that we can use. Everyone's too scared.
All right. Okay, next question. This is from Haziq Fikri. So by installing vertical wall to the current existing housing in Malaysia? Is it relevant, and does it improve green building movement? And why is Malaysia still not practicing vertical wall in low-rise?
Vertical wall as in vertical gardens, is that what you're saying?
I guess that's what Hazid Fikri means.
I think that it's, I think I have to look at Singapore as because they are moving faster than us, and they have something called NParks, which actually, if you want a great resource of looking about vertical gardens and horizontal and roof gardens and all the rest of it, NParks puts a great document out. I think it's all to do with the maintenance of it. I think the future would be that we're going to have more and more individual vertical gardens, obviously, where people can have the containment and look after itself. I mean, for us, obviously, when we're looking at some of the buildings, I think that there's not been many successful. I mean, there's one tower here, the Jean Nouvel Tower. Everybody knows the Jean Nouvel Tower that's in near KLCC. I don't think it's been very successful how the green wall's gone up. But however, the hotel by Woha down in Singapore, which has the garden going up the wall, but also fed by horizontal gardens, which are L-shaped, because the plan is actually a cube, and it's a rotation of an L shape going up, which is very interesting because it creates internal courtyard spaces. So spatially, for me, that's very interesting. And they're actually doing the vertical planting from these levels, so they actually have a much better idea how that works. But yeah, I think we'll see more of it. I'm not a big fan, as I say. I'm more for putting gardens at the levels in a proper manner, because I think just maintaining it will be much easier. And people want to go out into a gardenscape, even if it's on a higher level. Sort of thing. Yeah.
All right.
Yes.
Our next question will be from Arca, ARCA. So his question is, what are your thoughts about timber high-rise using cross-laminated timber, CLT? There was a news about Malaysia adopting glulam a few years ago, back as structural element, but there is still low adaptation about timber being accepted as resilient permanent structural element as compared to concrete. Is there a way that we as architects can improve and promote it?
Yeah, I think so. I think we should be looking at more glulam construction and cross-laminated timber. The ones that are going to be produced for university in plan looks a bit like Harriet Ward in terms it's 2 wings with but it's a square building. It's going to be constructed all in timber. It's also probably about 5 or 6 stories. I wouldn't be surprised that they're doing the glulam either in Indonesia or in Johor. So Johor, we have the glulam guys. They actually did the pavilion in 2015 at Malaysian Pavilion. Out of glulam. I just think that our code on fire hasn't addressed glulam construction just yet, because you have to take another a look at your fire provisions in order to have glulam in a high rise, especially after the fire in England. Nothing to do with glulam, but because of building facade. So building facade now, if there is no break level per level, you actually have to provide breaks level per level. So it's really, I think, about familiarization about fire. And I think, yeah, I think you should study it and maybe do one with glulam construction across in your unit. As a way of looking at that, because I think that's the way of the future.
All right. Our next question will be from Azlan Ali Arif, one of our lecturers. So he says, thank you, Serina, for the insightful sharing. My question would be, what would be your approach in making green roofs more accessible and public friendly instead of being exclusive buildings feature with high maintenance costs in the long run?
Well, I think the cost is probably now medium range. It's not low range in the sense that low cost housing is going to find it a little bit tough, except that if you're going to put it on top of car park spaces. So you'll start to see for Singapore, for example, that they've actually put on top of car park, although they don't have a lot of car parks because they're on a 70-30 car split. I don't know whether you know that. So that means 70% is public transport and 30% is individual mobility. As you can see from our numbers, we are probably at 90% car owner individual and 10% public mobility. But on top of car park spaces, if you were going to do that and pull the car park away as a different block of building and do green roofs on top of that, because the concern you have is about maintenance and water, right? And there's enough that's been done, except that you need to, of course, check how you build. And it is slightly more expensive. I wouldn't say it isn't. But I think there's a way around it if we approach it in that way. I wouldn't put it on top of housing per se. The example that I showed you, like for example, Harriet Ward is actually a double roof. We have MAP underneath it. So our MAP is underneath that. It's connected to a district cooling. If you know about district cooling, and you probably won't because it's a bit complex, but it's also, I wouldn't say it's a renewable energy, but it is lower energy for anybody. And in Putrajaya, you have district cooling. So when you have a big enough development, you can create district cooling. And so in this building, it was a double roof. And you'll find that probably in Singapore, most of them that have adopted a roof is a double roof. They use the MAP space as the gap in case there is any penetration and still use the roof. But we are not doing urban farming. Singapore is already embarking on urban farming, but we are not, because we have this mentality, we've got a lot of land around us, so we probably would need that. I see Anwar Yusuf has a question.
All right, okay, my name is Anwar. I'm from UiT Ministry Iskandar Perak, lecturer in architecture. Right, thank you very much indeed for your presentation. It's I think student can learn a lot from your presentation. It's very green. Right, I just got one question, probably slightly different from the rest of the student. Well, okay, my question, by looking to the content of your presentation, I keep asking about one thing, which is the competency skill that required by the student. So what are the key competency skills that required at your office for any graduate student want to be in your office? Thank you.
I think that students, we don't take too many students.
Graduate students. Yeah.
I think that exploration and innovation are probably one of the key factors of what we look for from students. In the sense, from their schoolwork, we can already see that they approach a little bit differently. You don't have to have all the skills to know how to do, the BEI, the OTTV. These things will come. It's a learning process. It would be great if the universities are already teaching you, some of the key criteria to look for when you're designing for a building. But it is something that you are learning together with us. And the designs are actually done together from the beginning as a team. In other words, we already engage with the MAP. We prefer to work with sustainable consultants that also have a different viewpoint, because our traditional MAPs are very traditional. It's just, I'm going to calculate the the amount of air and all the rest of it. Even for something like as small as the Malaysian Pavilion, we roped in a Singapore sustainable unit to work with us to do the calculations, because, you know, who knows about zero carbon? You know, who knows about embodied carbon? So collaboration is very high. I think being open, innovative, having the skills, obviously having a little bit stronger basic skills of construction or buildability is also important, because I think what I'm finding is that a lot of graduates don't know how to draw. And again, I go back to, I am not old-fashioned. Just saying to you that I can pick out faster than you what is wrong, maybe because of experience, but also about scale. But no, I think I would say going forward, I hope that everyone's being trained to parametric, because I think that fast building can also come from parametric. Ideas can evolve from parametric. So that as a tool is very important, I think, going forward. Having a little bit of an analysis brain, in the sense that when you approach the site, you're not just looking at, you know, this, and that's being able to step back a little bit. But, you know, that also comes with experience and a bit of confidence, really. So.
Thank you very much indeed.
Molam, you can open your mic, your Thomas.
Yes, thank you for your presentation. I was just wondering that, because you showed us the UAE project, and since it's a very arid country, right, the arid climate, so, and as we know, 40% of the energy usually goes into you know, cooling and dehumidifying in these countries. So I was just wondering, because you said it's net zero, and that's why I wanted to know the definition of net zero in your opinion, because what are actually the strategies that you're going to use to cool down, you know, because you need like massive cooling load. And
yeah, we do have, I mean, you know, it's interesting you ask this question. You know, in the end, we had a very small site. Our site is in the sustainable region of the expo, but we're right at the end of the street. So I hope we, those poles that you see, they are actually lit with LED lights, and they will flicker like fireflies at night. So they will flicker. Essentially, you know, the same thing goes. We thermal bridging, you know. Interesting for UAE. These guys, they came back, the Department of Civil Defense is their sort of DBKL, DCD, Civil Defense. They look at thermal bridging. That means the materials and that you're insulating. We have, the walls are insulated. So the first thing, like if I was going to build a data center, the thing to do is to insulate your building. So in this case, we insulated the walls.
Yeah.
Our material is timber, so the transfer is low in terms of heat, but wherever the metal steel frames are, we have to have thermal bridging happening there. The second is we have introduced something called the fat wall for air conditioning. We are basically cooling again from low displacement. We're throwing from the side, but at low level, because it's more efficient than throwing from the high point. If we get the displacement of cool air on the floor, then the hot air is rising naturally. So we'll be able to reduce the cooling load by about probably 10 or 15%. So first defense is the building envelope in any climate. Second is the type of air system that you're going to introduce. Now, if I was going to do another building, we actually have heli fans. You know those heli fans on the external? They're basically a big air fans, but on the outside. Yeah. They're basically to just draw some air through the space at the ground level. And then we have a sunken garden for the business center to bring light in, or indirect light. Also note that in Dubai, the expo is only open during the winter months, not in the summer months.
Yeah.
So in the winter months, they don't hit more than 35, 32 degrees Malaysia climate-wise, but it's slightly cooler and drier because it's, you know, it's not humid.
And I'm sorry, I have actually 5 questions, but can I ask another one?
Sure, go.
Because
Go
you showed us the project that is above the trees for the palm and the palm site. So I was thinking that Malaysia is a very humid country, and personally I've been like involved in many sustainable projects, even though I'm not Malaysian. But I've noticed that controlling the humidity is really a big challenge, and if you are surrounded by so much lashes of green, this is going to be even more challenging. So now the question is here not cooling, because I'm sure that you can do the cooling part, but how are you actually going to dehumidify, whereas the whole point is to, you know, blend with nature? Because again, a natural ventilation might naturally happen, but how to control the humidity?
You know, you can't control humidity on the outside. That's the first thing to know. But we need shade. So in the design for Penang South Island, shade and the loggia, the 3-meter loggia, is introduced to all building typologies in order for us to get shade. So the first thing you want to do is to promote shade. The second is that...
I'm sorry, 3-meter what?
A 3-meter loggia, that means it's a passageway that is 3 meters deep around buildings.
Okay.
Just like what Putrajaya is doing, you know, it's basically to create shade. And the thing about greenery, so you want to introduce the trees. You may not want to introduce so much shrubs close to your building because of mosquitoes and other things, but you want to introduce trees for shade. Why? Because in the urban heat island, you can reduce your temperature by 3 degrees.
Okay.
Dr. Hassan Sani already did the study when we were doing Telecom Malaysia. He used to give me this lecture. You can reduce by the shade of the trees by 3 degrees. And in fact, St. Paul promotes this. But you keep as green grass areas, and then you move away your bushes slightly away from your building so that you can get the natural ventilation or any ventilation to work a little bit better. That's the only thing that you can make temperate sort of humidity.
And another question is that I'm so sorry that Hijjas is so big, and I only came to know about it when they actually started building with BIG, because at that time I was doing my sustainable architecture in Penang Island, and it was a very big hit. But are you actually building on reclaimed land with BIG?
Gamuda is.
I'm sorry?
Gamuda is. We are not building it, but yes.
And again, because you are somebody that
I know, and as soon as an article came up in LinkedIn, somebody made the comment, Serina Hijjas, blah 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 blah, sustainability. Why is she doing the reclamation? I got to give you a little bit of insight. We did propose a different method. That's all I can say. There is a different method, but it isn't adopted. But it would still mean building out on that water location. I'm not saying we are the gods of sustainability, but every move that we've made in creating the island has worked very hard to replenishing back, restoring back after whatever we've done. If you know that southern portion a bit more, you will know that it is actually very low water and mostly floodplain. It's mostly siltation, and the water depths are not very, very deep.
You mean the Gurney side? the Gurney?
No, Gurney is up on the northeastern side. We're talking about the southern side.
The southern part.
And in fact, we went to interview on the first day of competition, unlike everybody else.
And
we went to interview the fishermen.
Yeah. And also, I had a friend who recently, and we also had a student who went and joined BIG to work on Malaysia's project. But she went there because we felt like we really often, again, like I didn't actually want to ask this question, but because one person asked about your process and competency to get into your office, she actually had to go work for BIG in order to be able to contribute to her own country. And I'm also an outsider. I'm not even Malaysian, but I feel like
she works for BIG, but she's from Malaysia? No, I don't think so. I know everybody that worked on it from big.
Yeah. Okay, but I mean, like, there are actually potentials in this country, and there are so many graduates in like PhDs in sustainable architecture, and we actually also do calculations and energy modeling, and we do parametric design, and not only the form making. We kind of make building energy efficiency and other things that you said just by digitization. But somehow we feel like there are either not many openings, or they are so internal that we don't even get our hands on them. Like I have a job now. I'm actually a lecturer in university technology.
Fantastic.
And I'm super
now
happy.
Now is not the time anyway, to be honest with you.
But I mean, like, it would be very nice that like Malaysian, especially good firms, to have a little bit of like transparency in terms of opening of jobs for students, because I see my students are like so excited. And what's the point of putting so much effort and doing all this energy efficiency if it's not even getting them a job, you know, and then they have to ultimately move outside. So
sure. I understand completely. You know, unfortunately right now is exactly not the time. In fact, most firms have downsized. And well, let's hope next year because I think it will take at least another year before we see the change again.
We hope so. Thank you so much. I spoke a lot, but I really hope to see a zero energy buildings in Malaysia, because it's been like 11 years now I'm here, and
absolutely
we still have very less GBI indexed buildings, and I hope
absolutely correct. It doesn't have to be just GBI. You know, as a promoter of Malaysian Green Building Council, is just that the country has not made it mandatory, and we really need to make it mandatory. Not because you're going to choose just GBI, there are many others, but we need to hit this target. We really need to hit this target.
Thanks for everything that you're doing. Thank you. Thank you.
All right, thank you, Molem, for the very insightful questions. All right, our next question will be from Amirul Hafiz. His question is, what is the challenges and barriers to the implementation of green building in Malaysia?
Perception. I think, you know, it's still a challenge. Although I've got to say that most big corporations now, the Gamudas, the Samdabi developers, all the big names the big developing names have to actually put in a sustainable report at the stock exchange. And this alone is starting to transform their thinking that every project has to be sustainable. We would not be having this conversation if this didn't happen 2 years ago. So the Sunways, the Samdabis, if you're going to join, you know, even as an architect outside, or Gamuda, you know, join these companies who are on the stock exchange, who are already having to make a commitment to ESG and UN Sustainable Development Goals. And because of this, we're seeing them think, oh, when I go and do my township, I'm going to think about a low carbon city. You know, how am I going to approach my town planning to become a low carbon city? We are only starting to hear this conversation, you know, as of 2 years ago. And I totally agree. You know, we are really not pushing hard enough. As I said, government needs to make this policy, and then it will be everywhere. It will become what we need to do. not just the exceptions.
All right, thank you. So I think after this will be our second last questions. So if there should be anyone who wants to ask, please be prepared. So our second last question would be, in your opinion, does Malaysia has the ability to become a net zero and green city just like Singapore and is going forward to? And what approach or actions that Malaysia can take to achieve the net zero from micro and macro stand of view?
So there was a study that just came out on the 21st of June, I think, with regards to our low carbon approach. All cities, most of the major cities in the world, from New York City to London to Australia to Singapore to Kuala Lumpur, and Kuala Lumpur also. I mean, Kuala Lumpur, I mean Penang, Kuala Lumpur, Johor, the major cities. Funny enough, in Kelantan is required to do energy efficiency for your building submissions, and that is Kelantan. It's not compulsory in this country, even though it's been put into the UBPL. So I don't know why it's been mandated by Parliament, but we've not mandated it right across as compulsory. Anyway, come back to that. I think Malaysia needs to not keep changing its policies because of change of government. That to separate between its policy and its politics, in order for us to really make the change that we need to make. In any other country, the policies separate from the politics, but in our country, the EE Act was supposed to come out last year, did not come out last year because of change of government. It was already finished. So, we the people really do have a good voice to make this happen then. So we have policies, but we are not making targets. And I think until you make targets, can you know that you can achieve or not achieve it? By translating your policies to targets, to real targets, you may fall short of it. There's no doubt about it. You may hit it exactly, but at least you have a target that you are aiming for. And I think this is where the weakness is. It's the same thing for us all, we think about, oh, I have this kind of idea, I want to do this. But so what are you really setting as your target? Then if you fall short of that, then okay, you evaluate. It's no problem to reevaluate. I think it's quite ironic that, Mahathir had the 2020 vision. And in 2020, we hit the pandemic and we did not hit this vision because of change of politics. So we have been very, very strong, and we need to get back to that level. I mean, I'm Malaysian through and through, and I just, although looking a bit Saleh, I think it's a pity. We have so much resources, and what we don't know is how to appreciate the resources that we have. We have in abundance. And actually, that makes us more powerful than Singapore.
All right, that's nice to hear. So before I proceed to the last question, I would like to ask if there's any lecturers who would actually want to ask a question. No lecturers are going to ask. All right, so I'll just proceed to the chat box. So there's two questions. So one from Shaslin Suhaimi says that the developers have been using green in their developments as
greenwashing. Greenwashing, as it were.
Oh, all right. Developments as a lifestyle and a way to increase the value of the development. Can sustainability and affordability go hand in hand? And how do we, as architects and designers, can help in making the green developments more affordable?
So, have any of you got Greening Malaysia book, which GBI put out? So in Greening Malaysia, basically we've done a couple of articles and studies on the return of investment. We need to talk about money. Apart from talking about the carbon budget, we need to talk about money. And we have found that basically the return of investment is within 3 years. You can do all the bells and whistles, but you don't need to do bells and whistles. You can basically get, it's a bit like saying, do I get a Tesla or do I get a hybrid Toyota? It's all about value of what you put in, but you can still be efficient. So we have found you can definitely get a return of investment and get 30% reduction if you go for a certification within 3 years. So you need to talk with the developer in this way. And the second thing is, it's a requirement already under MS 1525 UBBL, I don't know, UBBL 23 or something like that. It's already a requirement. So to do energy efficiency is already a requirement. That's the new baseline. That's the new baseline. I like your question on landscape. For me, landscape, I used to do the presentation on landscape, that landscape was performing more than just landscape. And it's now coming to the front, that ecology is going to be the future. And landscapes are just not about, beautiful plants and spaces and things like that, but it can also do many things. So Bushan, for example, if everybody knows about Bushan development down in Singapore, is a bioswale. It used to be a big longkang, the normal drainage that we see around our cities, is big, what we call monsoon drain. It used to be that, and they changed it into an adaptive bioswale where the water levels could rise and the water levels could go down, and it did many, many different things. And in the pandemic, they found that more people spent time outside than they spent in the green and in the park, than because of the pandemic. And so I think that landscaping is definitely the future. Water conservation, I think there's a question here on water conservation. Various uses increasingly become a high priority. My question is, what are the strategies in water efficiency and landscaping when in design? Well, first of all, first use adaptive, use adaptive or Malaysian plants so that the water intake for those plants are adapted to our climate. Second is to consider drip irrigation, obviously. If you're going to do vertical planting, for sure you need to do that. And to have water storage and water collection.
All right.
I have a question, if
Okay.
you don't mind. Thank you for your very interesting talk. Earlier when you said about low carbon city and Malaysia has only, this is quite new, you said around 2 years, right? And then recently even Shah Alam is trying to implement this low carbon city.
The focus groups.
Yeah. So I was wondering, do you think we should, Malaysia, do you think it'll be in the, how do I say this? Do you think that a low carbon city is possible in the near future for Malaysia, as compared to, because we keep on seeing these frameworks, but we don't really, emphasize or implement it very well in our country. So do you think a low carbon city is possible in the nearer future in Malaysia as compared to in the later future? That's my question.
I think that you've got to have the strategic engagement to basically define your strategies and your targets, which I think is what Shah Alam is trying to do for its own state. There's a great document to look at, I think it's called 80 by 50 for New York City. and it basically looks at, you know, the strategies for New York City to transform itself to a low carbon. Now you can imagine that's a much higher density population. It's a much older population. It's got a lot of old buildings. It's got a lot of infrastructure. Even they are having to do that transformation. But I don't think it's easy. But I think that if you take a you take a calculation now where you are. So I think, for example, Johor, IRDA have done that. KL, I believe, have done that. Penang has done that. That they look, where am I now? And what can I transform? What are the easy wins to transform? What are the more difficult ones to transform? What are my targets for the next 10 years? And really plan for it. So it takes that kind of effort to see. For example, if it makes a policy that all new factories now have to have their own renewable energy on top of their roof. Is that a policy? That means going forward, no new developments of factories, all must have solar PV on top. All must be tied to the metering system that they were talking about. I was in the energy focus group, for example. The landscaping, what percentage of greenfield do I have per population? How much do I have to increase that to greenfield? Am I going to 14 square meters per person? Because that is what London is. London's at 14. That's why you go to London and say, oh, I feel so green. Melbourne feels so green because it's at 22 meters of greenery per person. You know, it's knowing where you are and knowing what are your targets and knowing what are your easy wins and what are your more difficult wins. And that it takes 2 or 3 years to analyze all that and then to change your policy. And for example, planning, I asked, why is it that you've not implemented the UBBL requirement of energy efficiency? Or we can't impose that. What do you can't impose it? It's mandated by Parliament. Why can't you impose it for your state? So it's, I mean, I keep harping about energy efficiency and renewable energy, but ecology is going to be the big area as well. So yeah, I think it's possible, but it takes a village.
Hi, Serina. Hi, sorry. I just want to add on a little bit. I'm so sorry. Tajudin here. Okay. First of all, thank you so much for the insightful talk. It's a very eye-opening topic, and it's actually the main concern nowadays in design. But just to add on, we know that Malaysia has abundant amount of natural resources, like from the land, water, wind, and solar. But in some designs, they are using
not wind.
Yeah, not wind. Sorry, but some designs they are using it in development, but some are not fully utilizing it. So when it actually, because some relates to the issue of mainly cost, and the question is what methods are actually to promote it in Malaysia to actually make sure that people use it more, as well as what we know that some examples are like Forest City, they are using fully like ecology design development, and then now most designs, most projects are being held by big developers. So I mean, what kind of methods are actually is best to promote it in Malaysia nowadays, especially for firms or young architects as well as designers as well?
I think you have to realize where that developer is, at what stage they're in terms of adaptability. We can't fight with every developer. You know, some basically don't want to talk about energy efficiency because they just think that it's so expensive. But you know, when we started out before, we didn't have low VOC paints. We have low VOC paints everywhere. We didn't have LED. We have LED everywhere. So a lot is already available. Then it comes to the design and orientation. And yes, you do need to get the efficiency. You know, you're always efficiency. And unfortunate for us, it's not to do with efficiency in terms of energy, but it's to do with land building cost efficiencies, right? I think you, if you don't know, then you cannot convince. So first you have to know, well, you know, we developed the calculator, the water calculator, for example. On GBI was developed for free for everybody, and so is the BEI is also for free for everybody. But the water calculator, if you feed in all the information, it tells you what is the optimum size of your water tank. So you don't have to, you know, do double the tank size. Or you can actually be clever and say, okay, I'll have a water body on the outside, but I'll lose a bit of evaporation from that, and I will use that as a source for my irrigation or whatever. So I think first of all, you've got to know a little bit more before you can kind of convince. And then it's not easy, not always easy, but it depends on the client. And more clients are looking for it. It's just that just don't give them bells and whistles when they don't need it. Don't give them a Ferrari when they're actually asking for a Mitsubishi. You know, because we got it quite wrong. Some people, the cost for going certification was like double the cost of some other people per meter square. And that's because they're like putting this, putting that, putting this, you know. So it really, you give yourself the knowledge, and then you can, if you empower yourself with the knowledge, and then you're basically saying, well, you know, it's also a feature, and it becomes something that people like, and all the rest of it. I think this is the way that you're going to be able to shift that mental perception.
All right, thank you, Serina. That was great. There was a lot of questions. I'm so happy that everyone wanted to know about net zero. So, okay, therefore, that was our last question. Thank you, everyone. Going on to the closing session, I would just like to remind everyone that we will have a photo session at the end of this program. So if you want to get ready or probably touch up your face, and now is the time, because we have almost reached the end of our program. But hold on, before we get to the end, I would like to invite Dr. Nurul Husna Kamarul Zaman, our course coordinator, to give the closing remarks.
Thank you, Miss or Madam MC for today. Alhamdulillah, we have reached our end of the session. Yet another inspiring and insightful session organized by our students and COSA, so both Center of Studies for Architecture and the students, architectural students. Sorry. Yep, this is the sixth session from the one of Malaysia's prominent architect. They are Serina Hijjas, and the topic this time is, let me recap some of the information given. The high rise to low rise towards net zero. Thank you, Serina, for such an inspiring and insightful sharing session, which covered, from a session, it's again, we understand that architecture is, as they say, mother of all arts, while aesthetics and the scientific are intertwined together. So let me recap some of her sharing, which includes you need to understand the global issues like carbon emission, understand the site forces well, understanding the social aspects, including comfort, human comfort, exploring possibilities in materiality and construction. And she also showed us some endless possibilities to engage with nature, both in high-rise and low-rise building typology. So some buildings that she shared with us today includes the Menara Rebung, a high-rise building, low-rise buildings such as the Harriet Watt University, Malaysia, and the Malaysian Pavilion. All right. Thank you again, Serina. I learned a lot today. I believe all of us and all of us learn a lot as well. Okay. My greatest appreciation goes to COSA and Archisa and all the attendees who participate in this session today. You have chosen to be here to add into your knowledge this evening. Thank you so much.